Okay, in this video, we will graph two different graphs, one with secant and one with cosecant. So in the previous video, we kind of left off by the directions on how to graph the cosecant and secant curves. And here we'll do some two examples. So the first thing is that we want to graph the secant curve. So secant of 2x minus pi over 3. So remember that the first step in this case would be to start by graphing the sine or cosine curve, depending on which one it is. So if you think about the secant is the reciprocal of cosine. So what we're instead going to graph, we're going to graph y equals cosine of 2x minus pi over 3. Okay, so ignoring the vertical shift. Okay, so we're not going to do the vertical shift. Now, thankfully here, there's no vertical shift, so we don't have to worry about it. Okay, so now let's start off by graphing the cosine. So remember the cosine of this guy, we're going to start with the argument. So we know that 0 is less than x, is less than 2 pi. We're going to put the argument in the inside, 2x minus pi over 3. This is going to be between 0 and 2 pi. We're going to start by adding the pi over 3 to all three sides. So this is going to go away. 2x is between pi over 3. And then over here, we're going to take 2 pi, and we're going to add it to pi over 3. And that's going to give me 7 pi over 3. And now let's divide by 2 to all of the sides. So you know that x is going to be between pi over 6 and 7 pi over 6. Okay, so this is where the cycle is going to be. Okay, so now let's graph this. So here is pi over 6. Here is 7 pi over 6. And here what we're going to do is we're going to look for the midpoints. Okay, so we're going to start off with the first midpoint. Okay, so the way that we're going to do it is we're going to start off by taking 7 pi over 6 and adding pi over 6. So 7 pi over 6, adding pi over 6, and then dividing it by 2. That's going to give me 8 pi over 6 divided by 2, which gives me 8 pi over 12. Divide both top and bottom by 4. Or actually, I can divide both top and bottom by 4. Okay, so what I'm going to get is, divide this by 4 is going to be 2 pi. This guy's going to be 3. So 2 pi over 3. Then I'm going to add pi over 6 plus 2 pi over 3 divided by 2. Okay, so I'm going to use my calculator. So I'm going to have pi over 6 plus 2 pi over 3. And then I'm going to divide this by 2. I'm going to get 5 pi over 12. So this guy's going to be 5 pi over 12. And then I'm finally going to take this 2 pi over 3 and this 7 pi over 3, pi over 6. So 2 pi over 3, I'm going to add it to 7 pi over 6 divided by 2. So I'm going to have 2 pi over 3 plus 7 pi over 6, and I'm going to divide this by 2. And I'm going to get 11 pi over 12. So this guy right here will be 11 pi over 12. Now notice here that my graph, my amplitude is just 1. Okay, so let's just start by graphing the cosine. Cosine starts at 1, so we're going to start at pi over 6 because that's where it starts, pi over 6. 1, 0, negative 1, 0, 1. So my graph looks something like this. Now remember, this is just a cosine graph. What we want is the secant graph. So we need to flip everything. Now before we flip, where are the asymptotes? So the asymptote, there's an asymptote right here. There's an asymptote right here. And now what we're going to do is flip everything. Okay, so flip this one and then flip this one. So now let's draw a new graph. I'm running out of space, but let's start by drawing a new graph. So I'm going to draw it right here. Okay, so here's pi over 6, 5 pi over 12, 2 pi over 3, 11 pi over 12, and then 7 pi over 6. And my asymptotes are at 5 pi over 12 and at 11 pi over 12. I have a 1 and a negative 1. And now let's flip it. So this graph kind of looks like this. Okay, and this is good enough. Okay, so this is kind of what the graph looks like. So this would be the solution. One other way that you can do it is just erase this blue graph. So you can erase it and you'll get the answer also. Okay. All right, so basically it's things that we've known already. The only thing that we're doing is just adding asymptotes and then flipping it around. Okay, so now let's do the last problem. Now in this case, there's a -1. So basically this -1 is going to be at the end. We're going to do that at the very, very end. We're going to do everything also. Okay, so the first thing that we're going to do is we see that this is a cosecant here. So instead of the cosecant, what we're going to do is we're going to graph the sine. The sine of x plus 2 pi minus 1. Okay, so we're going to start off with the argument. So we know that x should be between 0 and 2 pi. So we have x plus 2 pi is going to be between 0 and 2 pi. So I'm going to subtract this 2 pi to all sides. And we see that it's going to be between negative 2 pi and 0. Okay, so this is where the new cycle is going to be at, which is basically the same one, but it's now on the negative side. Okay, so if I were to graph this, this is going to look a little bit different. Okay, so we're going to have this thing, but on this side. Okay, so on the negative side. So you can see that it's going to start at negative 2 pi and then end at 0. Now this is kind of it's kind of like deja vu, but in the opposite direction. So you can kind of think about this as negative pi over 2, negative pi, negative 3 pi over 2, 2 pi. So you kind of didn't really need to figure out what the middle points were, because you kind of already knew them, because they're kind of the same in the positive side. So now what you want to be able to do, now that we kind of know where all the endpoints are, all the points are at, now we got to take care of this amplitude, which is a 2. That means that instead of a 1, we're now going to be at a 2. So the amplitude in this case is going to be at a 2. So remember that the sine function, so if we look at the sine function, we know that the sine function is now going to be starting at 0. Okay, so we start at 0, okay, with the 2 pi. Then we're going to go up to 2, 0, down to negative 2, and then back to 0. So the sine curve looks like this. Now we're not going to do the vertical shift. We're going to do the vertical shift, remember, at the very end. Okay. Now at this point, what we want to do is we want to flip everything. Okay, so we want to start off with the vertical asymptotes. So the vertical asymptotes are going to be wherever it crosses 0. So this is where it crosses 0. And now we're going to flip everything. Okay. Okay, do you see this? Okay. So now what we're going to do, now is where we're going to flip it. Okay, so let's go ahead and graph it one more time a little nicer. So you have kind of like a negative 2 pi, negative 3 pi over 2, negative pi over 2, and then 0. So the graph itself, remember there's asymptotes at negative 2 pi and at negative pi and at 0. And then you have these graphs at 2. So here's 2, here's negative 2. So that this guy is going like that, and this guy is going upward. So now what you want to do is now you want to finish it off by using this negative 1. So remember this negative 1, what it's doing is that it's going to shift everything down by 1 unit. Okay, so we're going to go down 1 unit. So nothing is going to happen with the x value. So it's still going to be 0, negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. Now this guy was, the asymptotes stay the same. Okay, so the asymptotes are always going to be the same. This guy was at 2. I'm going to go down 1 unit, so it's now going to be a negative 1. Now this guy's going to be a negative 1. Okay, this guy right here was at negative 2. Now I'm going to be at negative 3. It's going to be down here. Okay, so that's basically what the graph is going to look like. So this is the graph of the original, which is basically this guy. So that's the graph. Okay, so these graphs are not that bad. Just graph the sine and the cosine function, and then you just got to flip everything else.